So hopefully you are good. It's been a long weekend. So yeah, we're gonna start with triangular matrices. And then we're gonna move on to determinants and with Cramer's law. So with triangular matrices, we have three types. We have the first one, it's called a diagonal matrix. So you have this diagonal here. The diagonal has numbers like this. And then you have zeros above and below the diagonal. It's called the diagonal. And then we have an upper triangular. An upper triangular, it means you have numbers on the upper side of the diagonal. So you just highlight the diagonal here. And then the diagonal together with the zeros here. The zeros, you only have zeros below the diagonal. This is the triangle. It's upper, it's on the upper side. And then the lower triangular matrix is the opposite of upper triangle. You have the triangle on the lower side. So what you need to know specifically about diagonal matrix, this one, you have the inverse. Imagine this is A. A is equal to, maybe let me call this B. We call this C. Imagine this matrix is A. The inverse of A, if it's the diagonal matrix, it's gonna be easy. You just take the inverse of the number of the main diagonal. So here it's gonna be 1/2, 1/3, then 1/4, and you're done. And 0, 0, then the zeros don't get affected. That would be your inverse, only for the diagonal matrix, not this side, only for the diagonal matrix. And then A squared, for example, you want to take A squared or whatever number, A squared or A10, just gonna use A squared. It's simple. It's just 2 squared, 3 squared, 4 squared. And then you insert your zeros. Oh, what just happened here? It's gonna be 3 squared, 4 squared, then you put the zeros. Right. And then, what else? And then another thing that you need to know about triangular matrices is that the determinant of any triangular matrix is just the multiplication of it's a multiplication of the diagonal. So determinant of triangular matrix is equal to multiply the entries of the main diagonal. So in this case, if we had to find the determinant of A, e.g., the determinant of A, it will be 2 times 3 times 4. That of B, you look at the diagonal, it's 1, 3, and 2. And that of C, it will be 1, 2, and 2. Yeah. Okay, with this one, with the diagonal, I forgot something with the inverse here. If, for example, for some reason, your diagonal has a 0. Let's say, for example, let me just remove this, put it this side. And let's say we have D, measures D, that is equal to 1, 0, 0, 2. Let me just put it 0, 0. Say we have a 0 here. We've got a 0 here. We've got a 0. We've got a 0 here. We've got a 0 here, and we've got a 3. Right, like this. This is a diagonal matrix because if we can just highlight a diagonal here, that's what diagonal matrix, right? Because if you highlight the diagonal, you have entries below. You've got 0 entries above and below. When it comes to diagonal matrices, if the matrix is like this, you cannot find D, I. It's not possible. And the reason is because, remember, with the diagonal matrix, you have to inverse the diagonal entries like we did here. We said here we said it was 1/2, and then 1/3, which is the inverse of 3, and then 1/4. But when you look at this one, it's gonna be 1/1, but then there's nothing, you cannot have 0/0. So just gotta be careful with this one. So that's all with triangular matrices. So we can just move on to determinant, unless you have questions on this page. Yep, can move on. We don't have questions here, right? We can quickly move on. Because I'm gonna like when you're doing with determinants, I will keep on coming back to this. So you need to understand this, especially this one, how to find the determinant of a triangular matrix, diagonal, upper or lower. So you need to understand. So now we're dealing with determinants. So with determinants, you need to know 3 things. You need to know that there are two. We need to know 3 things, right? We need to know how to find the determinant by cofactor expansion. And then we also need to know how to find the determinant by row reduction. Those are the 2 ways of finding a determinant. But there are other techniques, but these are the 2 official ways of finding a determinant. Right, and then once you are able to find a determinant, you need to be able to solve for an augmented matrix or a system of equations using Cramer's rule. Cramer's rule. So these are the three things you need to know and the determinants. You need to understand all three of them. So we're gonna start with and then this one, let me just combine these two. Right. You can find a determinant using by cofactor expansion or by row expansion, right? But you can also use both of them to find a determinant. You could use both of them at the same time, which is the one that's mostly used. You can use both of them to find a determinant of a matrix. So let's just start with cofactor expansion. Cofactor. Cofactor expansion.
That's the only thing that's left. That's the only thing that's left.
Dobego, can you read? Yeah, thank you. Expansion, right? So when it comes to cofactor expansion, you need to know what is a minor of entry of an entry. Oh my God, your internet connection is unstable. I think it's the wind here. There's so much wind here. Can you hear me, guys?
Yeah, we do.
Yeah, because they just reported that my internet is not stable. So I just keep on asking you every now and then. So you need to know what a minor entry, a minor of an entry, basically a minor of a number. I'll just come back to it now. Then you need to know a cofactor of entry ij, and we denoted Cij, right? So imagine we have some matrix, just put a random matrix, 3, 5, 6, 7, 4, 3, right? Imagine you have this matrix. An entry, it would be one of this. The ij is just means, for example, 2 here would be entry row 1, and then let me just highlight a different one. Let me highlight this one. Let me highlight 3. So 3 would be entry A row 1, column 2. Basically, the entry here is number 3. That's the entry. So if you had to find entry 1, 2, it means basically the number here. So a minor, basically what the minor is it's a determinant. A minor is just a determinant. The determinant is just a determinant of a submatrix, of a submatrix. After deleting ij, basically after deleting row I and column j, that's your minor. In this case, for example, if you had to find minor 1, 1, right? That means we need to find the determinant after deleting the first row. That's this one means first row. And then after deleting the second, the first column as well. So it's a determinant, remember, determinant, it's this line, determinant. Let me change this. I'm trying to change the color. Determinant, this line, a very straight line means determinant. It will be the sub matrix. In this case is what gets left behind after deleting. So basically it's the determinant of the matrix that remains. We call it a minor. And then a cofactor, basically, if you know how to find a minor, then the cofactor is just C Cij is equal to negative yi plus j, and then mij. So if you can find m, then you already have. You just need to play around with the negative here. Then you have a cofactor. Oh yeah. What else do we need here? That way. Yeah, maybe we should just do. Oh, another. Like for example, you have how many entries do you have here? 1, 2, 3, 4, 5, 6. Can you hear me, guys?
Yes, we
No?
do.
Okay, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. All of these numbers are called entries, right? It means we're gonna have 9 entries, 9 entries, which means that we will have 9 cofactors, right? Or minus. Right. So now if they ask you to find the determinant using a cofactor expansion, right? It will be, for example, let me just make an example using a question, because I think it's easier. It's easier to explain like that. Let me just make a quick example. Let's say we have this matrix, right? And then we have 3, we've got 1, we've got 2, we've got 2, we've got 6, we've got -4, we've got -1, we've got 3, right? Now, to find the determinant using cofactor expansion, if they specifically say cofactor expansion, right? It means the determinant of A will be equal to some entry. It'll be some entry multiplied by cofactor I. Let me just say 1 here, j plus dot A1 column n, and then Ci column n, right? If they say find a determinant using cofactor expansion, a determinant should be something like this, right? They might say using the first row. let's say find the determinant along the first row, right? So along the first row, what we need to do here, we know that it's gonna be 3. 1, 2, 3. We're gonna have, that means we need to use 3 cofactors.